morning, 6th grade. Happy Wednesday. Hope you're doing well. We're going to start by going over the follow-up question from last time. It said Alice, Raul, and Maria are baking cookies together. They need 3/4 cups of flour and 1/3 cup of butter to make a dozen cookies. They each brought the ingredients they had at home. Alice brought 2 cups of flour and 1/4 cup of butter. Raul brought 1 cup of flour and 1/2 cup of butter. And Maria brought 1 1/4 cups of flour and 3/4 cups of butter. If the students have plenty of the other ingredients they need, sugar, salt, baking soda, etc., how many whole batches of a dozen cookies can they make? All right, so let's look at the problem. For flour, each batch requires 3/4 of a cup. For butter, each batch requires 1/3 of a cup. So let's see how much flour we have. Alice brought 2 cups of flour. Raul brought 1 cup of flour. And Maria brought 1 1/4 cups of flour. Altogether, that's 4 1/4 cups of flour. That's the total. For butter, we see Alice brought 1/4 of a cup. Raul brought 1/2. And Maria brought 3/4 of a cup. If I add this up, 3/4 plus 1/4 is a whole, I have 1 1/2. So now I'm asking myself, if I want to know how many batches I can make, how many groups of 3/4 fit into 4 1/4? Which is a division problem. Same thing here. How many groups of 1/3 fit into 1 1/2, which is a division problem here. So I could make a model, which if you wish to do that, that's fine, or I can use the algorithm. So I'm going to change this to an improper fraction, which is 17/4 divided by 3/4. Okay? So now I can do that using the reciprocal method. 17/4 times 4/3 gives me 68/12, which I need to change to a mixed number, which would give me 5/8/12. If I divide this fraction by 4 to simplify it, I get 2/3. So how many batches could I make with the amount of flour I have? 5 2/3. Now, let's go back up here to the butter. I have 1 1/2 as an improper fraction is 3/2 divided by 1/3. Take the reciprocal. 3/2 times 3/1. It's 9/2. This gives me 4 wholes and 1/2. So here, with the amount of butter I have, I can make 4 1/2 batches. But the problem is asking, given both sets of ingredients, how many complete batches can I make? Well, I can't make 5 complete batches because I don't have enough with butter, so I can only make a total of 4 complete batches. All right, here's our warm-up. Fishing Adventure rents small fishing boats to tourists for day-long fishing trips. Each boat can hold at most 8 people. Additionally, each boat can only carry 900 pounds of weight for safety reasons. Let P represent the total number of people. Write an inequality to describe the number of people that a boat can hold. Draw a number line diagram that shows all possible solutions. Well, if I have 0 people, okay, we know that P, it can be greater than or equal to that number, okay? But we have to put a limit on the other side. P also has to be less than or equal to 8 because the boat can hold at most 8 people. So if I draw this out using a number line, I want us to think about something. People are individuals. You can't have a half a person. So I'm going to label this 0, 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to have a closed circle on each. So that means I can include any of these amounts of people. Again, I cannot have a half a person, a quarter of a person. That's why the circles are closed on all the whole numbers. Okay, let's look at the next one. Let W represent the total weight of a group of people wishing to rent a boat. So if you weigh something, your weight has to be greater than a number. In this case, 0. You can't have a negative weight. So 0 has to be less than or equal to W. So the weight W has to be greater than or equal to 0, but the boat can only carry 900 pounds. So we have to stop at 900 pounds. The weight of the boat can be less than or equal to 900. It cannot be 900.5. It could be 899 safely. So if we make a number line of this, here is 0. Here is 900. We have closed circles on this, so we can include those amounts. And the weight of the people can all be between these two parts, 0 and 900. Let's look at the next problem. Here is our Buc-ee's challenge for today. It's called the log ride. The theme park has a log ride that can hold 12 people. They also have a weight limit of 1,500 pounds per log for safety reasons. If the average adult weighs 150 pounds, the average child weighs 100 pounds, and the log itself weighs 200, the ride can operate safely if the inequality is satisfied, as A is the number of adults and C is the number of children in the log ride. So here's the inequality. 150 A as an adult plus 100 C for children plus 200 is less than or equal to 1,500 pounds. This is saying that the log can't be greater than 1,500 pounds. There are several groups of children of differing numbers waiting to ride. Group 1 has 4 children. Group 2 has 3 children. Group 3 has 9 children. Group 4 has 6 children, while Group 5 has 5 children. If 4 adults are already seated in the log, which groups of children can safely ride the ride? I would like you to pause now and go ahead and write down things you notice and wonder. All right, here are some of my notices and wonders. The log has a weight limit of 1,500 pounds, meaning it cannot go over 1,500 pounds. The average adult weighs 150 pounds. The average child weighs 100 pounds. The log weighs 200 pounds. A is the variable that represents the number of adults. C is the variable that represents the number of children. For the ride to operate safely, the weight must be under 1,500 pounds. 4 adults are already on the log ride. That is not going to change. Wonders, if 4 adults are already on the ride, how many kids can join them? Will we have to plug in different amount of children for C? Will the adults stay the same or change? Will the weight of the log stay the same or change? Here is the problem again. I would now like you to pause the video and solve the problem on paper. Please use any strategy that you know how to do. Let's try and see how many children can safely ride this ride given this statement of inequality. So we know A is the adults, C are the children, 200 is the weight of the log, and it all has to be less than or equal to 1,500. So we already know 4 adults are seated in the log ride. So I'm going to plug in a 4 for the A. Write everything else the same way. Now, if you remember, a number next to a variable is called a coefficient. And when you substitute a number in for the variable, it tells you to multiply the coefficient by the number you substituted in for the variable. So this means 150 times 4, which is 600. So the adult weight is approximately 600 plus 100 children. 100 times 100 is the weight of their average weight for each child times the amount of children, plus 200 has to be less than or equal to 1,500 pounds. Now, let's look at this here. If I add up the numbers I know, I have 600 plus 200, that's 800. This now is the weight of the adults plus the weight of the log. And we know this has to be less than or equal to 1,500. So now, there's different groups of children. So we're going to write down the groups. We're trying to see, could we have 4 children? Here, let me label this better. How many children make sense? So we're going to say the number of children that could go. Could 4 go? Let's look back up on the problem. We have 4 children, 3 children, 9 children, and 6 children. Remember, the weight has to be less than 1,500 pounds. And this, as I said before, is the weight of the adults now, plus the log. So let's substitute in. If I put 4 in for C, 4 times 100 is 400, right? So that would be 800 plus 400 gives me 1,200. 1,200 is less than or equal to 1,500, so 4 children can go safely. I'm going to put a check. Now, if we know 4 children could go safely, that also probably means 3 children could go safely because that's less. But let's plug it in. 3 for where the C is, 3 times 100 is 300 plus 800, 8 plus 3 is 11, is 1,100. 1,100 is less than or equal to 1,500. So far, 3 works. Let's try 9. 9 times 9 is going in for the children. 9 times 100 is 900 plus 800 equals 1,700. 1,700 is greater than 1,500. It is not less than or equal to, so 9 does not work. Let's try 6 children. 6 times 100 is 600 plus 800 equals 1400. 1400 is less than or equal to 1500. So 6 children could go. So based on the inequality, and to make this inequality true, it is safe to have 4 children, 3 children, and 6 children ride this ride, assuming there are 4 adults already on the ride, plus the weight of the log. All right, so after processing what we learned in the log problem, here are some reflections. To determine how many children could ride on the log ride, you needed to substitute in the number of children for C and then solve the inequality. Remember, in this example, the weight of the log itself was constant or did not change and was always 200 pounds. Also, like you did with the children, you needed to substitute 4 in for the number of adults A and then solve the inequality. The difference between the children and adults was the number of adults never changed, so the average weight of those 4 adults did not change. Here is your follow-up problem. At SeaWorld San Diego, kids are only allowed into the air bounce if they are between 37 and 61 inches tall. They are only allowed on the tide pool climb if they are 39 inches tall or under. Represent the height requirements of each ride with inequalities. Show the allowable, or the heights that could be true, for the rides on separate number lines. Using inequalities and a number line, describe the height of kids who can go on both the air bounce and the tide pool climb. Questions. If you have questions about anything I discussed or have answers to the problems I left you to solve, please email me or Mr. Lengthy your responses or send us a message on Dojo. I will respond to your messages in my challenge for Monday. Please remember, you have a group Google Meets meeting with either me or Mr. Lengthy this week. I miss you all. Hope you're doing well. Talk to you soon. Bye, guys. Just chillin' after the really long math problem.